Rowing is one of the oldest forms of water transportation known to man. It is based on the propulsion of a boat through the manipulation of oars. This crew boat, called a shell, contains 8 rowers who propel the boat through with oars, as quickly and efficiently as possible. There is also a coxswain who sits at the front and navigates and encourages the crew. A rowing stroke consists of 4 major phases: the catch, the drive, the release, and the recovery. These phases each demonstrate the presence of physics within rowing. Isaac Newton's third law of motion, often called the law of action and reaction, discusses how within certain reactions 2 bodies apply forces to one another that are equal in magnitude and opposite in direction. On a boat, rowers push water in one direction with an oar, resulting in the boat being propelled in the opposite direction. This very theory is why a rower faces 180 degrees away from the boat's intended course, so that their generated energy will move the boat forward as a shift in direction occurs. The quantity of water a rower can propel, and the faster they can achieve this, the faster and more efficiently a rower will move in their desired direction. The build of a rower is also very important. Elite rowers have a tall frame to best extend the oar over the water. Tall and strong rowers have long and strong strokes that allow them to propel the boat through the water. Speed and efficiency come with the strong technique and raw power that experienced rowers possess, in addition to a hydrodynamic hull and oar design. Hydrodynamics, a physical science often known as fluid dynamics, is the study of how an object moves through water. In rowing, the concept of hydrodynamics directly corresponds to resistance. Resistance is the drag produced by the oars and the hull of the boat. Resistance slows the boat down by introducing friction between the boat and the water. Less resistance means a faster boat. The majority of a rowing boat comes into contact with water, causing skin drag, foam drag, and wave drag. An understanding of resistance is critical in boat design and production. Boats are often altered based on new research, like the replacement of wooden boats with fiberglass or carbon fiber ones. The hull, body of the boat, accounts for 90% of the created drag. A stiff hull gives the boat less flex on each stroke's release. When a boat flexes or bends, it changes direction and lowers the boat's potential maximum speed. In general, longer and slimmer boats give less resistance, displacement, turbulence, and wake. The oar and the blade also contribute to the boat's hydrodynamic potential. An oar is a shaft of wood or carbon fiber with a curved blade and a rounded handle. Blades are slightly curved at the sides and the tips in order to increase water movement and efficiency. A flatter and larger blade, while it will move more water on each stroke, will create far more amount of drag, as it moves through the drag and air resistance on the back half of the recovery. Rowing is a very complex sport, and it embodies a variety of physical science concepts. The study of physics and hydrodynamics helped isolate the science behind rowing by breaking down and highlighting the individual features of a rower's complex stroke. Boat and oar design, technical adjustment and rower style, and the body of build are important factors